So hello everyone, this is Ankita Rajput and welcome to 4piacademy classes. And in this video we are going to cover the questions from the recent GATE Physics 2022 examination. And this is the part 1, and in this section we have included many questions from directly from the GATE question paper. So this is the part 1, and later we will also uh, come with other parts. So let's start. So first problem is this is from quantum mechanics, okay, and the problem is the wave function of a particle in a 1D infinite well of size 2a at a certain time is this. So this is a wave function, and probability of finding the particle in n equals to 2 state at that time is. So in this problem we have to find the probability of finding the particle in n equals to 2 state, okay, and wave function is given at particular time. So this is the 1D infinite well of size 2a, okay. So this is your wave function, okay, and we can check whether it is normalized or not, but it's normalized. And how we will check the condition of normalization? It's Okay, so first we need to square this psi x square. That the square of this term will be 1 upon 6. Okay, and how we can do this? Let me just. Okay, so for normalization condition, we will check this condition, and it should be like 1. Okay, so once we will do this, the a value comes out to be 1. Okay, so this is kind of normalization wave function. Okay, so now we will check what is the wave function for one dimensional infinite well of size 2a. Okay, so in generally we take the size a or size L, and in this case we write that the wave function is under root 2 upon L sine n pi x upon L, right? But here the L value is 2a, the size of the well is 2a, so the wave function comes out to be under root 2 upon 2a sine n pi x upon 2a. So this is the wave function. But in this problem we have to find the probability. We have to find the probability in n equals to 2 state. So for this we will take this. So this is the formula of probability in this given region 0 to 2a. Okay, so we will put the value of psi x, but for n equals to 2 state. So for n equals to 2 state, your n will be 2. Your n will be 2, and you can also check there's this wave function. This wave function corresponds to n equals to 2 state, because it should be sine 2 pi x upon 2a. So 2 से 2 cancel out हो जाएगा, so it's sine pi x upon a. So this is the formula, and the wave function we will put is this. Okay, so we will take this value. Okay, we will take this value. This is your psi 2. So mod of psi 2 x square will be the probability. So we will put this value, and we know how to integrate this expression. Sine square pi x upon a will be 1 by 2, 1 minus cos 2 pi x upon a. So we will integrate this, and the integration of 1 will be x, and integration of this cos term will be sine, and this constant a upon 2 pi. So we will put the limit here from 0 to 2a, and it will be 1 upon 6a outside, 2a minus a upon 2 pi sine 4 pi, and we know that sine n pi value is 0, so this second term will be 0. So 2a upon 6a will be 1 by 3, that is 0.33. So this is the probability, and we have to find the probability in percentage. Okay, here in percent. So 0.33 will be 33%. So the probability will be 33%. The next problem is, this is from solid state physics. In a two-dimensional square lattice, frequency omega of phonons in the long wavelength limit changes linearly with the wave vector k. Then the density of state of phonons is proportional to. So we have 2D square lattice, and frequency omega is proportional to k. So omega is proportional to k here, and in case of phonon we know that energy is h cut omega. Okay, what is the frequency, what is the energy in case of phonon? E is h cut nu. E is h cut nu, so E is directly proportional to omega. Okay, and this is the formula. In our classes we have already discussed these things, so this is a shortcut trick. So if E, energy, is proportional to nth power of wave vector in d dimension. So d is the dimension and E is proportional to nth power of k, wave vector. So we can find out the density of state using this formula, means dE proportional to e to the power d minus n over n. So in our case, frequency is proportional to k. So simply E is proportional to k because it's phonon. Okay, so n, we will compare this equation by E proportional to k to the power n. So n will be 1 from this equation, and we have in 2 dimension this whole case. So d is 2. So how we can find out the density of state? It will be proportional to e to the power d minus n upon n. D is 2, n is 1. So it should be proportional to E, and E is nothing, h cut omega. So density of state should be proportional to omega. So option A will be the correct option. So this is a very common trick and very important. Third problem is from EMT. A plane polarized electromagnetic wave propagating in YZ plane is incident at the interface of two media at Brewster's angle. Taking z equals to 0 as the boundary between the two media, the electric field of the reflected wave is given by. So आपको plane polarized electromagnetic wave given है YZ plane में. Okay, and उसका आपको reflected wave given है. So this is a reflected wave. Okay, and then which among the following statements are correct? So these are the four statement, and this is a MSQ, means more than single options will be correct here. So in 4 में से हमें check करना है कि कौन से options correct हैं. So okay, so ये आपका इंटरफेस हो गया z equals to 0. Okay, and आपका this is your EI. Okay, incident electric wave vector, and this is your reflected wave vector ER, and this ER is given. This ER is given to you. Okay, and okay, so this is your reflected angle and this will be your incident angle. Okay, so from this equation we have two components of E, means EY and EZ, and from these values we can find out the value of that tan theta. So tan theta will be EY upon EZ. So this is EY, this is EZ. So EY will be under root 3 by 2 and EZ is 1 by 2. So this value will be under root 3. Tan theta is under root 3. So theta will be 60 degree, or we can say pi by 3. So now we have the reflected angle. So reflected angle is how much? Pi by 3. So let us check the options. Reflected angle is pi by 6. So here option D is correct. Okay, reflected angle is this. Okay, so let us okay, sorry, so this is pi by 3. Okay, so reflected angle is not, yes, so reflected angle is not pi by 3, it's pi by 6. Okay, so let us check, because angle of refraction is also given here. So let us check the angle of refraction. So as in our case, our reflected angle is 60 degree, pi by 3. So we can calculate the angle of refraction. So angle of refraction will be 90 minus 60 degree, that is 30 degree. So it will be pi by 6. So that means your option A is your correct option. Okay, the angle of refraction is pi by 6. Okay, so and yeah, and the second thing, the incident wave can have components of its electric field in YZ direction. So ER is given in Y or Z plane. So incident wave, it's possible. So this option is also possible. And we have also this option. So this is D is the wrong option, A is the correct option, and C is also correct option. So let us check B. In B, the ratio of epsilon 2 upon epsilon 1 is 3. So let us check whether it's true or not. So this is theta I is basically Brewster angle. It's given in your problem. So what is the we can say Brewster angle formula, tan theta b is epsilon 2 upon epsilon 1. Okay, Brewster angle बोलता है कि tan theta b will be epsilon 2 upon epsilon 1, and this angle, the angle will be between the reflected and the refracted wave should be 90 degree, means theta r plus theta t will be 90 degree. And as we know that incident angle is always equal to the reflected angle, and I is how much here? Theta b. So basically theta b is equal to r, and we have calculated the r, we have calculated the reflected angle, and that was 60 degree. So basically theta b is 60 degree, and from this equation tan theta b, that is tan 60 degree, will be epsilon 2 upon epsilon 1, and tan 60 degree is under root 3. So epsilon 2 upon epsilon 1 upon root 3, but in questions it should be 3. So this option is wrong option. We have only two correct option, A and C. Okay, so this is how we can solve these types of problem. Okay, and this is from nuclear physics. Match the order of beta decays given in the left column to appropriate clause in the right column. Okay, so हमें इनको match करना है, and this is from the selection rule of beta transitions. So उसके लिए this is your list. This is a selection rule for allowed beta transition and forbidden beta transition. So allowed transitions के लिए आपका Fermi और Gamow के लिए आपका Fermi के लिए आपका delta I should be 0, and Gamow-Taylor में delta I should be 0 plus minus 1, and there is no change in parity in allowed transition. Okay, and in case of first forbidden transition, parity should change, and in Fermi selection rule, delta I is 0 plus minus 1, and in Gamow it should be 0 plus minus 1 plus minus 2. So as a whole we can say that in forbidden transition this delta I comes should be 0 plus minus 1 plus minus 2. Okay, and because in problem we have second and third forbidden transition, so this is the selection rule table for these second forbidden and third forbidden. So for second forbidden there is no change in parity, and this delta I or delta J should be 1 2 3, and for third forbidden this delta I should be 2 3 1, and there should a change in parity. Okay, so using these tables we can find out which selection rule is true. So for first one, okay, so this is first one, half plus, say half plus में transition. So we can check here delta I is 0, and there is no change in parity, parity में कोई change नहीं हो रहा. So it should be allowed beta transition because no change in parity and delta I is 0. Okay, so this condition is true, means this is the allowed beta transition. So the fourth one is, it matches with the fourth option, allowed beta transition. Okay, and next is second is 3 by 2 plus से 1 by 2 में transition हो रहा है. So here delta I आपका कितना आ जाएगा, delta I आपका कितना आ जाएगा, हम वेक्टर एडिशन कर रहे हैं. So it 1 और 2. Okay, माइनस से प्लस तक पूरे वैल्यूज, सो 1 और 2 हो गया, एंड पैरिटी में चेंज हो रहा है, देयर इज चेंज इन पैरिटी. सो लेट अस चेक change in parity, yes, and values are lying in this 1 2. So this is the first forbidden transition. So next is third is 3 प्लस से 0 प्लस में ट्रांजिशन हो रहा है. सो पैरिटी में कोई चेंज नहीं हो रहा, बट सिंपली डेल्टा आई की वैल्यू यहाँ पे 3 है. सो डेल्टा आई की वैल्यू 3 है, सो ये आपका हो जाएगा डेल्टा आई की वैल्यू 3, इसमें भी है इसमें भी है, बट देर इज 1 सेकेंड, देर इज नो चेंज, पैरिटी में कोई चेंज नहीं हो रहा, तो ये आपका सेकंड फॉरवर्डन ट्रांजिशन हो जाएगा. सो दिस विल बी योर सेकंड फॉरवर्डन बीटा ट्रांजिशन. फोर्थ आपको गिवन है 4 माइनस से 0 प्लस में, सो पैरिटी में चेंज हो रहा है एंड डेल्टा आई इक्वल्स टू 4. सो सिंपली ये आपका थर्ड फॉरवर्डन बीटा ट्रांजिशन हो जाएगा. सो दिस इज द ऑर्डर. 1 4 से मैच करेगा आपका, सेकंड फर्स्ट से, थर्ड आपका सेकंड से, एंड फोर्थ आपका थर्ड से. ओके, सो दिस इज योर प्रॉब्लम फ्रॉम beta transitions. So your next problem is from atomic physics. An excited state of calcium atom is given here. Okay, this is 3p5, 4s2 and 3d1. The spectroscopic terms corresponding to the total orbital angular momentum are. So आपको spectroscopic terms निकालना है for L. and for this excited state of calcium. So we can check for the unpaired electrons, means p5 और d1 के लिए हम check करेंगे. So how we will check? So this is your electronic configuration. So we will take for this p5 and 3d1 state. Okay. So for p5 के लिए for unpaired electron s1 आपका कितना हो जाएगा? Spin value will be half. और for d1 के लिए आपका, इसके लिए भी आपका जो स्पिन हो जाएगा वो 1/2 हो जाएगा. P स्टेट है तो L1 आपका 1 होगा, D स्टेट है तो L2 आपका 2 हो जाएगा. सो टू कैलकुलेट टोटल S वैल्यू हम क्या लेंगे? S माइनस S2 से मॉड S1 माइनस S2 से S1 प्लस S2 तक एंड ऑल दी वैल्यूज इन बिटवीन. सो ये आपके हो जाएंगे हाफ हाफ. सो 0 और 1 आपको 2 वैल्यूज मिल रहे हैं टोटल स्पिन एंगुलर मोमेंटम के लिए. सो वी कैन फाइंड आउट द मल्टीप्लिसिटी फ्रॉम एस वैल्यू. सो मल्टीप्लिसिटी कितना होता है? 2s प्लस 1. सो 0 के करस्पॉन्डिंग 1 होगा और 1 के करस्पॉन्डिंग 3. सो आपका s आ गया. एंड हाउ वी कैन कैलकुलेट द कैपिटल L वैल्यू? L1 माइनस L2 से L1 प्लस L2 ऑल द मॉड वैल्यूज. सो ये हो जाएगा आपका L1 इज हाफ एंड L2 इज 2. सो आपको कितनी वैल्यू मिलेंगी 1 से 2 में? 1 2 3. तो 3 values are here and 1 corresponds to P, 2 corresponds to D and 3 corresponds to F. Okay, so आपका जो terms होगा उसमें आपको P, D and F, P, D and F आपको स्पेक्ट्रोस्कोपिक टर्म्स मिलेंगे. सो आपका बी ऑप्शन आपका करेक्ट ऑप्शन है. एंड अगर आप फर्दर एग्जैक्ट टर्म्स निकालना चाहते हो तो यू हैव टू फाइंड आउट द टोटल J वैल्यू जो कि L माइनस एस से L प्लस एस होगा मोड वैल्यूज, एंड उसके करस्पॉन्डिंगली आप टर्म्स निकाल सकते हो एग्जैक्ट. ओके, सो दिस इज हाउ यू कैन सॉल्व दिस प्रॉब्लम. सो ऑप्शन बी आपका करेक्ट ऑप्शन है. ओके, your next problem is from EMT. A point charge Q is performing simple harmonic oscillations of amplitude A at angular frequency omega. Using Lamar's formula, the power radiated by the charge is proportional to. So ये बहुत ही सिंपल फॉर्मूला है. आपको सिंपली पावर रेडिएटेड बाय द चार्ज आपको बताना है. सो जो पावर रेडिएटेड होता है दैट इज प्रोपोर्शनल टू ओमेगा टू द पावर 4 Q स्क्वायर ओमेगा 4 A स्क्वायर. सो आपका ये वाला ऑप्शन करेक्ट है, डी ऑप्शन. Okay, so this is from atomic Zeeman effect. For normal Zeeman lines observed parallel and perpendicular to the magnetic field applied to an atom, which of the following statements are correct? So normal Zeeman lines hai, and these lines are observed parallel and perpendicular. So parallel means what? Longitudinal mode में उनको देख रहे हैं, and perpendicular means in transverse modes. Okay, to the magnetic field. So हमें इन स्टेटमेंट में से देखना है which statements are true. So first is only pi lines are observed parallel to the field. So first thing I want to tell you, don't confused about like in pi lines the electric vectors are parallel to the electric field, magnetic field, and in sigma the electric vectors are perpendicular to the field. Okay, so उसको इससे confuse मत करना, because here they are saying that the lines which we can see in longitudinal and transverse mode, हमें वो देखना है कि उन मोड में कौन सी पाई या सिग्मा लाइंस ऑब्जर्व होती हैं. सो इसके लिए yes, you can see this image. Okay, so this is here you can see, and you can also remember like this is a longitudinal mode means the parallel to the field. So in this longitudinal mode we get only sigma lines, we get only sigma, we can see only sigma lines. There is no pi emission, there are no pi lines. So sigma x and sigma y emission हमें इसमें मिलता है. तो sigma y and sigma x के जो मैग्नीट्यूड है दे आर डिफरेंट. सो हमें सिग्मा लाइन मिलती है जो कि सर्कुलरली पोलराइज्ड होती है. सो देयर इज नो पाई कंपोनेंट्स इन longitudinal mode. So okay, so only sigma lines are observed parallel to the field. So ये वाला आपका ऑप्शन करेक्ट होगा. only pi lines are observed parallel to the field because parallel means longitudinal. So longitudinal में आपका sigma नहीं मिलता, सिर्फ pi मिलता है. तो D ऑप्शन आपका करेक्ट हो गया फर्स्ट. सेकेंड थिंग, ट्रांसवर्स मोड में आपको पाई मिलता है, लीनियर पाई एमिशन. यानी कि आपको प्लेन पोलराइज्ड पाई कंपोनेंट मिलता है एंड सिग्मा, इसमें सिग्मा वाई नहीं मिलता एंड सिग्मा एक्स एमिशन होता है। मींस एक ही सिग्मा सिग्मा के सिंगल कंपोनेंट का एमिशन हो रहा है, तो इसमें पाई एंड सिग्मा दोनों ही प्लेन पोलराइज्ड आपको मिल रहे हैं इन ट्रांसवर्स मोड। इन ट्रांसवर्स मोड यहाँ पे भी आप देख सकते हो कि पाई एमिशन हो रहा है। सो ट्रांसवर्स मोड में मींस इन केस ऑफ व्हेन यू आर सीइंग परपेंडिकुलर टू द फील्ड, सो आपको सिग्मा एंड पाई दोनों लाइंस मिल रहे हैं। सो ओके ओके, so sigma lines perpendicular to the field are plane polarized, correct, because transverse mode में आपको sigma का सिर्फ सिंगल कंपोनेंट मिल रहा है, तो that will be plane polarized. And yes, C is also correct. पाई लाइंस परपेंडिकुलर टू द फील्ड मींस पाई लाइंस आपको ट्रांसवर्स मोड में मिल रहे हैं जो कि प्लेन पोलराइज है, तो ये तीनों ऑप्शंस आपके करेक्ट ऑप्शन है। ओके, तो ये क्वेश्चन थोड़ा कंफ्यूजिंग था बट डिफिकल्ट नहीं था। ओके, so B, C and D options are correct. And okay, so this is from Pauli's spin matrix. So you have to find the options जो Pauli spin matrices आपको satisfy करते हो। तो ये आपको पता ही होगा, these are the three Pauli spin matrices, sigma 1, sigma 2, sigma 3, sigma x, sigma y, sigma z भी कह सकते हैं, and we can also call them sigma alpha, sigma beta and sigma gamma, right? Okay, so these are the relation, these are the commutation relation. So आपका सिग्मा एक्स सिग्मा वाई माइनस सिग्मा वाई सिग्मा एक्स अगर आप सॉल्व करो, सो ये आपका 2i सिग्मा के होता है एंड ये आपका एंटी कम्यूटेटर, हम इसको रिलेशन भी बोल सकते हैं, मींस सो ओके, सो ये आपका हो गया। सेकंड आपका जो कम्यूटेटर रिलेशनशिप होता है सिग्मा एक्स सिग्मा वाई, अगर आप कैलकुलेट करोगे तो ये 2i सिग्मा जेड होता है एंड सिमिलरली सिग्मा वाई सिग्मा जेड 2i sigma x and similarly this. So आप इसको as a whole you can write this like commutation of sigma I sigma z will be 2i this this epsilon I j k and sigma k. So आपका ये जो ऑप्शन है ये आपका वन सेकेंड ओके, सो आपका इसका मीनिंग यही है, अगर आप इसको ओपन करोगे सो दैट विल बी अल्फा बीटा ले रहे हो तो अकॉर्डिंगली हो जाएगा, आई जे के ले रहे हो तो अकॉर्डिंगली हो जाएगा। सो मीन्स आपका ये वाला ऑप्शन तो करेक्ट है, बी ऑप्शन तो करेक्ट है। एंड आपका यस एंटी कम्यूटेटर अगर हम निकालते हैं तो एक्स वाई होता है, एक्स वाई प्लस वाई एक्स मीन्स सिग्मा आई सिग्मा जे आपका 2 डेल्टा आई जे होता है, और इसको अगर आप ओपन करते हो तो ये आपका होता है सिग्मा अल्फा सिग्मा बीटा, और आई जे के टर्म में अगर आपको बोलो तो सिग्मा आई सिग्मा जे प्लस सिग्मा जे सिग्मा आई विल बी 2 डेल्टा आई जे। ओके, सो यानी कि डी ऑप्शन भी आपका करेक्ट है। सो 2 ऑप्शंस आर करेक्ट हियर, बी एंड डी। Okay, so this is from superconductivity, very interesting problem. At T equals to 0 Kelvin, which of the following diagram represent the occupation probability of energy state of electrons in BCS type superconductor? So आपको BCS थ्योरी के अकॉर्डिंग सुपरकंडक्टर के लिए आपको 0 केल्विन पे आपको बताना है कि प्रोबेबिलिटी ऑक्यूपेशन प्रोबेबिलिटी और E में क्या रिलेशन है। ओके, सो आपका इसमें फर्स्ट ऑप्शन आपका करेक्ट होगा क्योंकि दिस इज फ्रॉम किटल। ओके, एंड दिस गेट क्वेश्चंस आर लिटिल ट्रिकी दिस टाइम एंड मोस्ट ऑफ वी कैन से फ्रॉम सॉलिड अगर हम बात करें सो किटल बहुत अच्छा था अगर आपने पढ़ा हो। सो दिस इज फ्रॉम किटल एंड दिस इज द एग्जैक्ट ग्राफ। सो दिस इज द प्रोबेबिलिटी वर्सेस ई ग्राफ फॉर दिस superconducting state at T equals to 0 Kelvin, and here you can see that at EF we can say at 0 Kelvin in this case the ground state differs from the Fermi state in a region below, and this is below EG. ओके, सो आपका जो ग्राउंड स्टेट से फर्स्ट एक्साइटेड स्टेट है उसके बीच में EG का डिफरेंस है। ओके, सो दिस ऑप्शन ए इज द करेक्ट ऑप्शन। Okay, we have already covered this problem and this problem. from solid state physics. Electronic specific heat of a solid at temperature T is this. C आपका gamma T होता है. This is the electronic specific heat formula. And gamma is a constant related to the thermal effective mass M effective of the electron. Then which of the following statements are correct? So this is also MSQ. So option R की gamma आपका proportional होगा M effective के. So and M effective is greater than free electron mass of all solids. So ये तो आपका correct नहीं होगा क्योंकि okay. So M effective and okay, M effective means effective mass आपका positive भी होता है और negative भी होता है. Means वो आपका जो free electron mass है उससे greater भी हो सकता है, less भी हो सकता है. It depends on different things. Okay, but this is not the correct statement. So okay, so rest we will check. So electronic specific heat formula is basically this. So this is the electronic specific heat, and from here you can see that this C is proportional to 1 upon TF, and TF is what? Fermi temperature. And how Fermi temperature depends with E, directly proportional. So EF is directly proportional to TF, and the EF is H square upon 2m and 3 pi square and over V upon 2 to the power 2 by 3. Okay, so from that formula EF is inversely proportional to M. Okay, so that means this gamma comes out to proportional to M. ये आपका M के proportional हो जाएगा, और we can say ये आपका M star M effective के आपके proportional हो जाएगा. So उस केस में आपका first option correct option है. So your first option will be correct option, that your that this gamma is proportional to mass or effective mass. Okay, and okay, and this is also I have taken from Kittel. Okay, so the statement is as it is given, that at temperature much below the divide temperature, okay, and also Fermi temperature, the heat capacity of metal may be written as, okay. So this specific heat is gamma T, and this is valid only when the temperature is much below the divide temperature. So that means option D is also correct option. So A and D, these two options are correct option. Okay, so this is all about this video, and in next part we will also cover some more problems from GATE examination. So thanks everyone.